Alrighty, so that was a nightmare. Um, it turns out that I did not put in um, duplication guards for collision. They're here now. We have our friendly registration state blocking duplications, um, and that is right now I have it going from currently deregistered to currently registered to um, to work with the commands and not have an include loop. This is the best way for me to run this now. So we register and we deregister. I had it open to test it. If I try to register twice, we should get an assert telling us something has gone horribly wrong. It did go wrong. Likewise, if we try and deregister twice, we should be fine here. And when we scene change, oops, we messed it all up. So that's good, that's friendly. And finally, if we get it all right, we do everything perfectly, we have Collidable working correctly, and when we change, then we're good. Perfect. Sorry about that. That's the end of the collision registration system. So the rest of this video is going to be the game object lifecycle, the visualizer, the math tool, and just the colors that I have going. So let's jump into the game object, everyone's favorite. Here is the full header file for game object, including lots of documentation for the submit entry and the submit exit. Where are those? As well as some private functions, connect to scene, disconnect from scene, a registration state, so I don't have to go and put that one in now, and a virtual destructor, everyone's favorite. This class inherits from the rest of these bad boys. That is the organization style. I chose the inheritance, not the other way around. So that is that. Here's the game object CPP, which has the same registration style that we've seen from the rest of the lower level base types. And this is the style when we go to the scene manager, or down to the current scene would be more helpful. Scene. If we follow this scene entry and scene exit, we will see these are triggered by the commands that we can go into for a moment. They connect to scene and disconnect from scene, which I should have kept this open. In turn, call the scene entry function for connect to scene and the scene exit function, which are both user-defined functions that are inherited from the game object class. And so those are called at the top of the scene, at the bottom of the scene, and wherever dynamic entry may be whenever you want to enter something into a scene or withdraw it from. So if we look at the commands, scene registration, here we are, game object entry. If we look into the execute for this one, it's just the connect to scene. when we shoot a bullet, then we get this connect to scene. I believe there was another connect to scene somewhere. I'm sorry that this is just so confusing for me. Alright, so that other function there does not do anything. It is never called. That's awkward. I'm not going to restart this video though, because we've established that it just doesn't do anything. So that's great. I could leave that breakpoint there all day. So these two are never called, but the command itself is called, and that's where the registration state is changed. The scene entry is called. So this all works. That was just a weird function that I haven't gotten rid of, and I'm a little embarrassed. So we've seen the scene entry and the scene exit. It is under the command pattern. We saw that. Exit request can be called multiple times. So I tested that the week that we implemented this. And where did I do it? I did it in the collision. Oh, I did it in the bullets. So the way that we tested that is, and it's still going. There it is. When the alarm is triggered, the bullets has a submit exit, and I also have it duplicated for a total of 4 times. And wrong key. Here we have 3 bullets going out, and they'll disappear one at a time. And as we can see, nothing has crashed. The submit exit was only processed the first time, so that's all good. And that is just, we don't assert for the registration state, we do a test, and if the test passes, then we go through with that. Otherwise, we just ignore the whole thing. Command pattern exit request, tested above efficiently. We just stop the command from being submitted. That's the level that we stop running it. It's just one if and an early out. Factory with an object pool, that is what these projectiles are. It's a bullet factory with recycled stuff. If we can get above the plane, where is it? It's during runtime. Here we are. We have the recycled stack size. Actually, if we want to see the actual recycling going on, here we have a bunch. We want to watch the output. There we see 11 of them are recycled. We got recycled bullets being used, and that stack grows up again. So all of that works correctly. And the live, yes, perfect. Let's jump into the visualizer quickly, because I know these videos are taking so long. Commands gone, visualizer. Those are the commands. We want the actual visualizer. There it is. So, visualizer is a singleton. It is deleted. We saw it earlier by the, I believe this deletes it, the game.cpp. There it is. It is deleted in the game.cpp. Whoa. Not by the scene like the multi-10 managers are, because it is the same for the command pattern. It allows it to be applicable across all scenes. So it's deleted by the engine. I didn't do the class diagram for this. I will bring the class diagram back, but I'll get the rest of it done here. Actually, I'll just go over the colors really quickly so I can end with this, and we can start the next video with the rest of the visualizer. Unless this has it. It does not. So, colors. Colors are Asset Manager. What I have here is the same colors file that we have in the graphics class, and the important thing here is we have static constant vectors um, that are just all stored here, and predefined static constant vectors for common colors, that's those. And then I don't even know, oh, we use them, they're very helpful for the visualizer, which is in the visualizer commands. Managers, scene management, commands, visualizer. Oh, it's in the test pair. So we have colors being used here. It's great. All right, so, and then the math tool is up here. We have this header file. Right now, only two functions. I have a distance between two vectors and intersection for two B spheres. And this is the math for those. Here's the collision math. It's very straightforward, and these are of course all static. We don't need an instance of this math stuff. So that is that. If we jump into the let's do the collision volume. Here it is. It allows for multiple or for derivations of collision volumes. This is Collidable group. Sorry, collision volume is just the header. We have the bounding sphere, which is a derivation of the collision volume, with a few just important collision volume things, and this the CPP, which allows for intersection between bounding spheres, which just calls the math tools. I just realized I need to rename PW math tools because PW stands for periwinkle. I did not know what that stood for before right now. So jumping into the visualizer, all the visualizer does is stores the models here for the visualized for right now it's just the bounding sphere, but it could be for all of the boxes and things that we will be adding next quarter. We have a list of the commands. Order doesn't matter, so we just keep them like that, and then this is just a command pattern of a list of the commands to be rendered. We will soon have many show commands and just an add command. I'm not going to go through the code, so sorry. Here's the CPP for the visualizer. For the commands, each command is going to have a command factory, and that will keep the commands from being created more than they have to. So if we jump into the command factory, I just want to quickly demonstrate that even while we're running, we're visualizing. If we stop here in the recycle, we see that there are only 2 active commands, and there are 0 recycled commands. So that is keeping the commands limited. What else do we need? Requests are done through the command pattern. That's what we just looked at. Single graphics object. Yes, there's only one of them. It's in visualizer here. This is the only sphere model being rendered. Show B sphere, we saw that. Render all, we saw. What is it? Visualize all is what I have here. And that executes every command, which renders every render command, and that is called down here in the scene. It's called between the 3D draw and the 2D draw, so that it can be accurate. The 2D things accurately lie on top of the visualizer. We looked at the delete. So good. Perfect. So at the top of the next video, we will see the file for this, and we'll see it then.